Hello, boys and girls. In lesson 7.2, we will determine the number of possible outcomes by creating a tree diagram and or using the fundamental counting principle. So let's start by using our prior knowledge to determine what we know about tree diagrams. Let's take a look at some vocabulary. In probability, a sample space is the set of all possible outcomes in a probability situation. For example, when you toss two coins, the sample space consists of four outcomes: heads on one coin and heads on the other, heads on one coin and tails on the other, tails on the first coin and heads on the other, or two tails on either coin. In order to be able to determine the sample space, it is possible to use a tree diagram. A tree diagram is used to determine the number of possible outcomes in a probability situation. The number of final branches is equal to the number of possible outcomes. Let's take a look at an example and create a tree diagram showing the sample space. So you are getting ready for your trip to Dorney Park. You ask to pick a drink and a lunch. The options you can choose from are listed to the side here. Can you create a tree diagram to represent all of the possible combinations? We most certainly can. So let's begin with our drinks. We have a choice of two different drinks: soda or water. There is a choice of three different lunch items. Therefore, we can have soda with a hamburger, soda with a hot dog, or soda with chicken nuggets. If someone else decides they want water, they also have the choice of hamburger, hot dog, or chicken nuggets. So therefore, there is a sample space of 6 different possibilities or combinations. You can have soda with hamburger, soda with hot dog, soda with chicken nuggets, water with a hamburger, water with a hot dog, or water with chicken nuggets. So there are a total of 6 combinations. So what is the probability of you choosing a hot dog? Well, when we look at our tree diagram, we can see that the hot dog is listed twice, once with the soda and once with the water. So there are 2 combinations out of 6 possible combinations, because again, we're comparing hot dogs to the total, giving us a probability of 1/3. Moving on, what is the probability of you choosing a soda? Well, if we're looking at this tree diagram, Again, we can have soda with the hamburger, soda with hot dog, soda with chicken nuggets, giving us a probability of 3 choices out of the total of 6 choices, or 1/2. Let's look at the following example. Which tree diagram shows all of the possibilities for tossing a coin and rolling a fair number pyramid that has 4 sides labeled 1 through 4? Why they say fair is because each side, 1 through 4, is equally likely to occur. Therefore, let's take a look at our choices. When we look at a coin, we can either flip heads or tails. When we roll the pyramid, we can roll a 1, 2, 3, or 4. So let's look at each tree diagram to see which one would be showing all of the possible outcomes. In A, they show a choice of heads only for flipping. Therefore, this could not be correct because we are missing the tail portion of it. In B, it shows the possibility of flipping heads or tails, but for each of those flips, it fails to show each of the 4 possibilities. So B is not correct. Scrolling along, item C shows that if you flip heads, you can roll a 1 and then a 1 again. That does not look right either. This should have been a 2, this should have been a 3, and this should have been a 4. So this is not correct. Let's see the last choice. In choice D, it shows that you can flip heads or tails, and for each of those flips, you can roll each of the possible numbers on that pyramid. So let's discuss the fundamental counting principle. In the fundamental counting principle, it states that if there are m ways to make a first selection and then n ways to make a second selection, then there are m times n ways to make both selections. Let's take a look at an example. For a lunch special, there are 2 outcomes for appetizers and 4 outcomes for the entree. So therefore, for each one of these 2 outcomes, there are 4 possibilities under each appetizer for an entree. Therefore, if we multiply 2 times 4, we get the 8 total outcomes. And again, the 2 is for the appetizers and the 4 is for the entrees. Let's try an example. Reggie has 4 pairs of pants, 5 shirts, and 2 pairs of shoes. How many different outfits or sets of clothing does he have? We can multiply 4 times 5 because for each pair of pants, there are 5 possible shirts, giving us a total of 20. And then for each of those 20 outfits, there are 2 pairs of shoes to choose from. Therefore, there are a total of 40 outcomes or 40 outfits that Reggie has to choose from. So let us use this in practice. A fast food restaurant has a meal special, $5 for a drink, sandwich, side item, and dessert. Listed are the choices. So, how many meal combos are possible? Well, let's take a look. There is one for grilled chicken. For the sandwiches, there are one, the grilled chicken, all beef patty, veggie burger, or fish fillet. For sides, there are regular fries, cheese fries, or potato wedges. For dessert, you have a choice of chocolate chip cookie or apple pie. And for a drink, you have a choice of a Fanta, Dr. Pepper, a Coke, a Diet Coke, or a Sprite. So let us multiply each of these. We will multiply the sandwich times the side times the dessert times the drink to give us our total number of outcomes. So 4 times 3 times 2 times 5. I will multiply 2 times 5 to give me 10 first, 4 times 3 to give me 12, 12 times 10 will give me 120 possible combos.